Okay, folks, so what we're looking at right here is what's called a ballistic pendulum, and that's what this lab is about. Effectively, what we have is a ball, a gun, and a pendulum. And what I'm going to do is I'm going to take this pendulum arm and I'm going to get it out of the way, and I'm going to take this ramrod, I'm going to put the ball in the barrel, and I'm going to use the ramrod to cock this thing. So now the ball is in position. When I pull this string, it will end up firing the ball. I'm going to bring the pendulum arm down like so. And I'm going to want to know when the ball comes in and it hits the catch, the pendulum arm is going to swing up. And I'm going to want to know at what angle, what the highest angle it gets to. And to do that, they have this clever device on here. There's a protractor here. And they have this little device that will move freely, or pretty close to freely anyway. And so as the pendulum arm goes up, it will just push that up, and then when the pendulum arm comes back down, it will leave that little nubbin wherever it is, and then you can just read off to see what the angle is. So right now, I'm looking at this thing, and it looks as though the little nubbin is sitting at about 1 degree. So it's not dead on 0, it's at like 1 degree. I'm going to go ahead and pull the trigger. The thing goes out, comes back. You can see the little nubbin has swung up to some angle here. And I'm going to read that angle off. And it looks as though the angle is, it's reading 2, 4, 6, 8. So it's reading 38, and if you subtract off that 1 degree, so it went up about 37 degrees. So we're looking at 37 degrees of a swing up. So one of the things that we need is the length of the pendulum arm. So we need to go from the contact point where it's swinging from to the center of mass of the system, which means we need to know what the center of mass distance is. So I'm going to go ahead and I'm going to try to balance this thing and see if I can't find the center of mass point. And it appears that the center of mass point is like right about there. So I need to know the distance between here, essentially, and here. So I'm going to go ahead and take the centimeter stick and I'm going to measure off. And I have 10, 20, I would say 29 centimeters. So apparently the pendulum bob length is 29 centimeters. So let me go ahead and check it one more time just to make sure. Okay, so that's about right. So once again, I'm going to go 29. And I would say this time around we're looking at, I'm going to say 28.7. So the pendulum arm length is 0.287 meters. The angle that it swung up to was 37 degrees. And we need to know what the mass of the ball and the mass of the pendulum arm are. So I'm going to go measure that right now. So I just went ahead and I measured the mass of the ball, and it came out to be 66 grams, which is 0.066 kilograms. And I measured the mass of the pendulum arm, and it came out to be 242 grams, which is 0.242 kilograms. So we're going to go ahead and try this one more time. I'm going to get the arm out of the way. I'm going to put the ball in, use the ramrod to cock it. Bring the arm back down. Take the little nubbin and bring it back down. Check to see where it is. And it's at about 1 degree. which is where it was before. I'm going to go ahead and pull the trigger. It's going to fly out, and it has come out to 38 degrees again. Subtract off the 1 degree, we're back at 37 degrees. Basically, it appears as though it's working. We're getting the same data consistently. So this is good. Okay, folks, so you've seen the ballistic pendulum part of the lab. If you look closely, you will notice I'm wearing a different pair of jeans. Actually, my first shot at this, I went ahead and did the lab and realized that you actually can't see the ball as it's being projected out into space here. So I've had to come back, and it's a Sunday afternoon, and I'm trying it again. I put down a black felt sort of carpet-like in the hopes that you'll have a better chance of being able to track the ball. And additionally, I've put down some paper, and I'm hoping that when the ball hits the paper, it will scuff the paper, so we'll have a good shot at how far the ball actually physically went. This part of the lab, effectively what we're going to do is I'm going to take the pendulum arm, I'm going to get it out of the way. So we're basically going to be using the device as a gun. And the gun is going to be shooting the ball straight out. So the initial velocity in the horizontal and the X direction is going to be the muzzle velocity. That's the thing you're trying to figure out. And I'm going to go ahead and I'm going to take the plunger and I'm going to put the ball in. And I'm going to cock this baby. And when we're ready to go, I'm going to pull the trigger and the thing's going to fire, and hopefully we're going to get some decent data. What we want, what we're hoping for, is the height that the body started out at, which is going to be hard to get, and then also the physical distance that the ball traveled horizontally. And with those two bits of information, you ought to be able to use kinematics to figure out what the muzzle velocity was. And we'll do it a couple of times just to see, make sure that the data looks decent. Having to do with where the body starts, the vertical part's pretty easy. I've got a meter stick here. I'm looking to see where the ball comes out, and I can see it's essentially 98 centimeters above the ground. So 0.98 meters above the ground is essentially Y naught, assuming that you make Y equal to 0, be ground level. The distance that the body travels horizontally is a little bit dicier, and the reason why is because the ball is going to come free back a little ways from the lip of the table. And additionally, these meter sticks, which I have on the ground here, are jammed up against the table, but the lip comes out. So we need to figure out how far the ball is going to go before it gets to where the tabletop starts down below, so that we can add on that distance to whatever the meter sticks read. So the way I'm going to do that is I'm going to measure this distance, and it turns out that the distance it's about 11.5 centimeters. And the distance from the edge into where the lip is 5.5 centimeters. So 11.5 minus 5.5. So basically you're going to have, the ball's going to go 6 centimeters before it gets to this spot right here, which is where the meter stick starts. So whatever number I read off here, we're going to have to add 6 centimeters on, and that will be the horizontal distance. Anyway, so this should be exciting. I'm going to pull the trigger and see where this thing goes. Hopefully you will be able to see, you should be able to see it start out. The question is whether or not it's going to be moving fast. And the question is whether you'll actually be able to see it hit one way or the other. If it hits and scuffs, I will be able to tell you what that value is. So here we go. 3, 2, 1. All right. So I'm looking at it. I can see the scuff mark is right here. It's at 2 meters, 16.5 centimeters. if we add on the 6 centimeters, it's going to be 2 meters, 22.5 centimeters. So I'm going to go ahead and write this down. 2 meters, 0.225. Okay. And then for the amusement of it, assuming I can find the ball, just wait. We'll try this again and see how consistent this gun is. So one more time with feeling. And it's hard to believe, but it actually hit in exactly the same spot. What can I say? All right, so this is what your data is looking like. Okay, you have the initial height, you have the distance that the body traveled in the horizontal, both these two data entries down here at the bottom. And so now you have enough information to use conservation of energy and conservation of momentum along with the data that you took from the ballistic pendulum setup to figure out what the muzzle velocity is. And you have the data from using the system just as a straight gun to be able to use kinematics to figure out what the muzzle velocity is. If you do those two derivations and then calculations, you should find that the muzzle velocity is what it is. I mean, it should be the same in both cases. Hopefully you'll have a fairly small percent deviation by the time you get done. So anyway, that's it. Enjoy.